Section 9. Present-day climate in your community. Digging deeper. Weather and climate. Factors affecting climate. In the Investigate, you analyzed and interpreted climatic data in several tables to help you describe the climate in your community. You then compared and contrasted your climate to that of a community far away from yours. In this digging deeper, you will read more about how physical features affect climate. Recall that weather refers to the atmospheric conditions at a particular time. The weather on a particular day might be cold or hot. It might be sunny or rainy. You often can recognize changes in the characteristics of the weather from one season to the next. Weather varies over a range of time scales from month to month, week to week, and day to day. Severe weather events illustrate just how variable atmospheric conditions can be over even shorter periods of time, sometimes only a few minutes. Climate refers to the typical or average weather of a region. It is a long-term average of the weather. For example, Alaska has a cold climate, but southern Florida has a tropical climate. Minnesota's climate is hot in the summer and cold in the winter. Western Oregon has a very rainy winter. Weather in each of these regions can vary from day to day, often unpredictably. However, each region has a definite climate. Shifts in climate are a natural part of the Earth system, but these fluctuations occur over significant intervals of time. The climate of a particular place on Earth is influenced by several important factors. These include latitude, elevation, and nearby geographic features. Latitude is a measure of the distance of a point on Earth from the equator. It is expressed in degrees. It ranges from 0 degrees at the equator to 90 degrees at the poles. The amount of solar energy an area receives depends upon its latitude. At low latitudes near the equator, the sun is always nearly overhead in the middle of the day, all year round. Near the poles, the sun is low in the sky in even summer. In the winter, it is nighttime 24 hours of the day at the poles. As a result, regions near the equator are much warmer than regions near the poles. Assuming a constant elevation, temperatures decrease by an average of about 1 degree Fahrenheit for every 3 degrees of latitude away from the equator. Elevation is the height of a point on Earth's surface above sea level. It also affects the physical environment of a region. Places at high elevations are generally cooler than places at low elevations in a given region. On average, temperatures decrease by about 3.6 degrees Fahrenheit for every 300 meters or 1,000 feet gain in elevation. In many places at high elevation, glaciers form. In these places, summers are not warm enough to melt all of the snow each year. Figure 1 shows the mountains in Glacier National Park in Montana. They are located at high elevation as well as fairly high latitude. As you can see, they contain glaciers. Geographic features. Geographic features, such as mountain ranges, lakes, and oceans, affect the climate of a region. Mountains can have a dramatic effect on precipitation in nearby areas. The windward side of a mountain chain often receives much more rainfall than the leeward side. As wind approaches the mountains, it is forced upward. When the air rises, it cools. Water vapor condenses into clouds, which produce precipitation. On the other hand, the leeward side of a mountain range is in what is called a rain shadow. It often receives very little rain. That is because the air has already lost much of its moisture on the windward side. When the air descends the leeward slope of the mountain, it warms up as the greater air pressure compresses it. That causes clouds to evaporate. The humidity of the air also decreases. The deserts of the southwestern United States have low rainfall. They are in the rain shadow of the Sierra Nevada and other mountain ranges along the Pacific coast. In Part C of the Investigate, you planned and carried out an investigation to gather evidence to help you explain the differences in the rates of cooling and heating of soil or rock and water. This part of the Digging Deeper will help you understand the relationship between water, land, and climate. Large bodies of water can also have a big effect on climate. The ocean has a moderating effect. At similar latitude, temperatures along the coast vary less than inland. This is true from day to day. It is also true from season to season. The effect is especially strong where the coast faces into the prevailing winds. For example, average temperature in San Francisco is 64 degrees Fahrenheit in July and 49 degrees Fahrenheit in January. Kansas City's average temperature is 79 degrees Fahrenheit in July and 26 degrees Fahrenheit in January. On average, New York City's January temperatures vary only 11 degrees Fahrenheit during a day. Omaha's January temperatures vary 20 degrees Fahrenheit during a day. In each of these two cases, the difference between the two cities' climates is too great to be related to their latitude. The difference in latitude is less than about 1.5 degrees Fahrenheit. Instead, the differences in climate in these two places are because of the presence of water. Water has a much higher heat capacity than soil and rock. That means that much more heat is needed to raise the temperature of water than to raise the temperature of soil or rock. In the same way, water cools much more slowly than soil or rock. Land areas warm up quickly during a sunny day. They cool down quickly during clear nights. The ocean and large lakes, on the other hand, change their temperature very little from day to day. The ocean absorbs a lot of heat during the day. It releases the heat at night. This prevents daytime temperatures in seaside communities from climbing very high. It also prevents nighttime temperatures from falling very low. This does not occur if the wind is blowing from the land to the ocean. In the same way, oceans store heat during the summer. They release it during the winter. This keeps summer cooler and winters warmer than they would be otherwise. Lake effect snow is common in late autumn and early winter downwind of the Great Lakes. The Great Lakes are located in the north-central United States. During this time, cold winds blow across the still warm lake water. The cold winds then accumulate moisture as they flow across the lake. When they reach the cold land, the air is cooled. The water in the air precipitates out of the clouds as snow. The warm oceans also supply the moisture that feeds major rainstorms. These storms occur not just along the coast, but even further inland in the eastern and central United States. The Köppen system for climate classification. The Köppen climate classification system is commonly used by scientists to describe climate types. It is based on the idea that climate is closely related to types of vegetation. The Köppen system subdivides terrestrial climates into 5 major climate regions. The divisions are based on average annual precipitation, monthly precipitation, and monthly temperature. Each climate has a 2 or 3 letter code. The first letter defines the main type of climate. Depending on the main type of climate, a second letter can be given to provide further detail. B-type climates are dry and arid. However, an S or a W denotes either semi-arid or arid. Note that not all codes apply to each other. For example, A-type climates are tropical and high in precipitation. Therefore, a second letter of S for low precipitation cannot be applied to this type of climate. The third letter describes temperature variations for B negative, C negative, and D negative types of main climates. For example, in the United States, the southeastern Atlantic coast is designated as a CFA. The C indicates a hot, moderate climate. The F stands for moist or humid. The A indicates a hot summer. The North Pacific coast is classified as CFB. In this region, the B indicates a warm summer, while the F indicates humid conditions and no dry season. Global climate. Climates differ from one region to another, depending on latitude, elevation, and geographic features. However, the entire Earth has a climate too. This is called global climate. It is usually expressed as the year-round average temperature of the entire surface of Earth. Rainfall is also an important part of global climate. Today, the average temperature on the surface of Earth is about 60 degrees Fahrenheit.